Okay, so let's try another example here about, let's do f of x equal to, I don't know, 2x times x plus 3, x minus 2, x plus 5, and let's divide that by 3x plus 1, and x minus 4, and then x plus 5. Putting a couple things together here. So hopefully you've noticed right now that there is a common factor on the top and the bottom, so we can take that out. Neither are squared or cubed or anything, so they both disappear, and that means that we have a hole in the graph, right? So we can immediately jump down to 2x times x plus 3, x minus 2, over 3x plus 1 times x minus 4. And we need to write x cannot equal negative 5. That's going to be a hole in the graph there. We've got to remember to put that in. Now the degree of the top is a cubic, so it's degree 3. The bottom is a quadratic, so it's one higher on the top than the bottom. We're going to have an oblique asymptote. Okay? So in order to find out what that oblique asymptote is, we need to expand this and do the long division. Okay, so from this though, before we expand, let's get the information about these zeros and all that kind of stuff. So these zeros are going to be x equal to 0, negative 3, and 2, based on the values on the top. And the vertical asymptotes are x equals negative 1/3 from here, and x equals 4. Okay, so that's the information we've got from that. Now let's try and find the oblique. So for the oblique, little title here, we're going to expand. Okay, and so we've got 2x times x squared plus 3x minus 2x, so plus x, and then minus 6, all over, and we got 3x squared, okay, and then we've got negative 12x plus x, which is going to be negative 11x minus 4, and one more time here, so we're going to get 2x cubed plus 2x squared minus 6x all over 3x squared minus 11x minus 4. So that's what this function looks like. Don't forget the x cannot equal negative 5, x cannot equal negative 5 part. Okay, otherwise we can't put an equal sign here, it's not the same. So now we're going to do the long division. Okay, so we're going to divide that cubic by that quadratic. This is going to get a little bit ugly, so I'll leave some space here. Okay, so 3x squared minus 11x minus 4, 2x cubed plus 2x squared minus 6x. Okay. So now what do we multiply 3x squared by to get 2x cubed? We're going to have to multiply it by 2/3 x. Okay, so 2/3 x. Okay, this is going to be ugly, so 2/3 x times 3x squared cancels out the 3's, you get 2x cubed. Now I got to do it to the rest of this. So 2/3 times 11 is going to be 22/3. Okay, so minus 22 over 3x squared. And then 2/3 times 4 is going to be negative 8, or negative 4, I mean negative 8/3 x. Okay, so you subtract this, So far, we're almost there. We just have to get one more term here to get the linear. We know the slope is going to be 2/3. Subtract that, you get 0 here. 2x squared minus negative 22 over 3x squared. Let's change the 2x squared to something over 3. That's going to be 6/3 x squared. So 6 over 3 minus negative 22 over 3 is going to be plus, so it's going to be 28 over 3 x squared. Okay, and then negative 6x minus negative 8/3 x. So that's going to be plus. So 6 times 3 is 18 plus 8. So negative 18 plus 8 is going to be negative 10/3 x. Okay. So now what we've got to do is get rid of this 28 over 3 x squared. Okay. So 28 over 3, well, we're going to multiply 3x squared by what to get 28 over 3? Well, 3x squared, let's do this over here. So 3 times what? Let's call it an a, equals 28 over 3, right? Well, that's easy. Just bring the 3 down here. So a equals 28 over 9. Okay. So 28 over 9 is what we're going to put here. That's an ugly number. Okay, so 28 over 9 times this will give me 28 over 3 x squared. And then we can follow through and multiply it by this, and then you subtract and you'll get a remainder. But at this point you're done if you're just looking for the oblique asymptote. Okay, so the oblique asymptote is just this answer on the top. So therefore the OA, the oblique asymptote, is y equals 2/3 x plus 28 over 9. Okay, which is kind of ugly, but that's the oblique asymptote. Now we can try and sketch this function with all the information given. This way, 28 over 9, well, 27 over 9 would be 3, so it's 3 1/9 basically, is going to be the y-intercept. So it's about here. 2/3 slope, so it goes up 2 over 3. So it's going to be like this. About like that. Okay. And there's the oblique asymptote. There's 28 over 9. And we label it y equals that right there basically. X, y. And this is what the function tends to as x goes to infinity. So let's look at the other information. So we've got now a vertical asymptote at negative 1/3 and 4. So at negative 1/3, maybe off scale here a little bit, negative 1/3, it's going to be a vertical asymptote. And then 4 will be out here. Okay. So there's our vertical asymptotes, about, not the best scale. And then we're going to put our zeros in, 0, negative 3, and 2. Okay, so 0, negative 3 is going to be somewhere out here, probably. Maybe not, maybe it's in here somewhere. 2/3, we'll see that in a minute. And 2, yeah, 2. So 2 will be here. Okay, so up here on this side, the function cannot go through the x-axis because there are no zeros out here. So I'm going to really exaggerate this up here. I'll go right through there. And what's happening here is the function is going to look like this. Okay. Otherwise, if it went down here, it would have to cut through the x-axis, and we don't have any more zeros. So this is the best part for that. Okay, we have a 0 here, and we have a 0 here. So what's going to happen here is probably it's going to go up like this, or down like this, or a twist in it. So let's take a look at the actual function at x equal to 2 here. So let's try at 3. So f of 3 equals, let's see if it's positive or negative, and we should be able to tell the rest from there. So if we look at here, f equal to 3, well, the top is going to be positive, 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 and the bottom is going to be positive, negative. So it's going to be positive over a negative, which equals a negative. Means on this side we're going to go down like this. And based on what we know about the factors, it's going to go up and back down like this. Okay, because they're linear factors. And then over here, well, I got to see where my scale is here. This was a 0 that was negative 3. Okay, so it might be here, it might be in here. Let's try and figure this out. To do that, if I plug in negative 3 into this line, let's see if the line is above it or below it. So 2 over 3 times negative 3, well, that's going to give me negative 2. Negative 2 plus 28 over 9, well, 28 over 9 is a little bit more than 3, so this is going to be positive at negative 3. So the line should have been more diagonal like this, and negative 3 would be in here somewhere. Okay, so negative 3. And because of that, well, let's see what's going to happen then. The function is going to, it's not going to just touch here and go down. It's probably going to come down like this, come through, and then go back. Okay, but, oh, sorry, you couldn't see that. So it's going to probably come down here, go through, and then come back. It's probably not going to just touch and go there, but we'll check a value. So there's negative 1/3, there's negative 3. Let's try negative 2. So f of negative 2. So negative 2, when we go back into the function here, so negative, positive, negative, so the top's a positive. Negative 2 here, so that's going to be negative, negative, and that's going to be positive on the bottom. So negative and a negative, so positive over positive, which means it's going to be up above. Okay, so it's going to come down like this, come through, and then I believe it's going to come back and look like that. And that's what that function would look like, except we've got one little problem here, and that is x cannot be negative 5. So let's say negative 5 is here, and then over here, instead of being solid, we'd have a hole. Okay, so there'd be a hole in the graph right there. And that's it for oblique asymptotes.